Hey everybody, this is Johnny, and I just wanted to touch base with y'all about the new Corsair ThermalProtect cable. This is not an official Corsair video. This is just me explaining a few things after having read a few of the videos that were online that kind of didn't quite answer some of the questions that people had and might have assumed some things that weren't quite correct. There was some really good math in some of the reviews, but not a lot of mechanical engineering type know-how thinking type stuff. Anyway, so this is one of my engineering samples. We've got a bunch of these with these thermal probes on it. I'll tell you a little bit about the thermal probes here first. So you can see they go into the connector here, and they actually go in and make contact with the terminal. So we're actually getting temperatures of the terminals themselves on these cables. You can see we've got some on the ground, we've got some on the 12 volt, we got some in the actual comb that holds a thermal switch. So I guess I should probably explain how this works before I get too deep into this. So the way this works, the ThermalProtect, is if this connector for whatever reason gets too hot, whether it's not fully inserted or maybe one of the terminals are damaged or whatever, and this gets hot, there's a switch in here that senses the heat and it cuts the Sense 0 and Sense 1 pins, which when the graphics card sees that, it shuts off the graphics card. Your screen goes blank. You could have a second monitor maybe plugged into onboard graphics on your CPU, so you see that something's going wrong. But it gives you the opportunity to open up the PC, look at this connector, see is it not plugged in all the way, is it somewhat damaged for whatever reason, like I said, maybe a split terminal or something, and either fix whatever's going wrong or replace the cable. Okay, so anyway, so that's what that's all about. So anyway, back to these wires. So we have all of these wires everywhere, and there's even an extra wire for ambient temperature because we do all of this testing in thermal chambers because we want to make sure we take into consideration, if your PC is say like 55 degrees Celsius inside, or maybe your graphics card is blowing hot air directly onto this part of the cable. Okay. So anyway, so all of these wires, they plug into the back of this thing here. This thing is a data collector, and it basically it shows in real time all the temperatures that are coming off of these. But also, what's really cool is we plug it into a PC via USB, and we can graph all of the temperatures too, or it's called a data logger rather. So we can, leave this thing running, on like a 5090 for like, a week, right? And we'll have a week's worth of data, all the temperatures going up and down, up and down. So it doesn't have to be like Furmark that's just running almost a static load for 24/7. We can have it benchmarking, 24/7, going through different routines, those kind of things. So anyway, moving on from that. So the way that this actually works, and something that needs to be considered. So, your wires obviously are made of copper, right? And copper is a really good electrical conductor. And it's also a really good thermal conductor, okay? So, as your electricity is going this way, the temperature of these pins are going this way, inside in the copper, okay? So, what isn't a good conductor is PVC plastic, PVC plastic, PVC plastic, and air, okay? So I heard it was said that, well, because this is here and this is here, that it's gonna take a really long time for this to react to this overheating, or the temperature of your graphics card blowing hot air on this is gonna make this trigger. Well, again, like I said, these parts are insulated by PVC plastic, okay? What's important is the temperature, or the hot, the high temperatures that are coming, that are occurring onto these terminals are taking a trip down this copper to the switch. Now, mind you, it's not like an instantaneous, as soon as this gets hot, which is why the temperature of the switch is significantly lower than what we expect this to get, when we consider too hot, for safe operation, okay? That's why this switch is only rated at 65C. Obviously 65C is perfectly safe operating temperature for this connector. This connector is actually rated for 105C. But you shouldn't think that just because it's 65C outside of this whole area of this cable, that this thing is just going to shut down, or that, you know, this thing's going to get 105C and somehow this temperature has to somehow traverse outside of the cable to this switch in order for this switch to operate. The switch is inside a comb for a reason. It's actually in contact with the copper of the wires because it's getting the temperature from the copper of the wires. Okay, so that's how this actually works. Again, you know, it's getting the temperature from here, it's taking that temperature along the copper wires, activates the switch, cuts off the sense 0 and sense 1, graphics card sees that, graphics card shuts down. Now I'm also going to show a second part of this video. It's going to show you some of the jigs I use to emulate improperly installed 12V2x6 connectors. I think you might think it's pretty cool.